Okay, let's have a look at the problems for homework 3. So the first one was to prove that when two lines intersect, vertically opposite angles are equal. So I was just looking for as simple proof as possible. So if we have our two lines like this, let's just say we have A, B, C, and D. A nice simple argument would be that straight lines have the same angle, so we could say that AC equals BD as our starting point. And if we call these angles alpha, beta, gamma, and delta, we see that what makes up AC is alpha plus beta, and what makes up BD is beta plus gamma. And so if we subtract beta from both sides, we end up with alpha being equal to gamma. And there's no need to bring in how many degrees we've got or whatever. It's just starting off the idea that two straight lines have the same angle measure. Okay, for the second problem, we're talking about Plato's dialogue, where the Athenian says, "But if, as I put it, all we Greeks believe them to be commensable when fundamentally they are incommensurable, one had better address these people as follows, blushing the while on their behalf. Now then, most esteemed among the Greeks, isn't this one of those subjects we said it was disgraceful not to understand? Not that a knowledge of the basic essentials was much to be proud of." Okay. And then there's this famous thing about supposedly Plato putting over the entrance to the academy, "Let no ungeometrical person come under this roof." And so I was just looking for some kind of discussion about this. So when Plato says, has this about above his academy, "Let no ungeometrical person come under this roof," this is kind of like, it's a common thing in temples and back in ancient days, the idea of purity, that if you were an impure person or it had an impure act or dirty, or some said you weren't allowed into the place. So Plato here is kind of being really serious and really taking himself seriously, I think, which is kind of much more than we can say than American culture. And so I think it's clear that's what happened here is Plato is thinking of geometry, he's placing it above arithmetic. So just, there's like basic knowledge. This in modern times, we think about, the knowledge you have just to do a job, to be like a carpenter or a plumber or whatever. But maybe there are things which make you better suited to doing an upper level job or something. This is all going into the liberal arts and sciences traditions that, we take seriously here at Truman. And so he's saying that geometry, with its kind of like its rigor, the idea of proof, it just kind of expands the mind in a sense more than, just adding numbers or doing arithmetic could possibly do. Okay, so here's the argument that, a possible argument that the square root of 3 is irrational. What we're directly proving is that square root of 3 and 1 are incommensurable. So we start off with square root of 3 and 1. Square root of 3 is bigger than 1. So we subtract 1 from square root of 3, and then 1 becomes the bigger. So then we've got 1 and square root of 3 minus 1. Square root of 3 minus 1 is a smaller thing, so you take that away from 1. Okay, and then the square root of 3 minus 1 is bigger than 2 minus square root of 3. And then we see that 2 minus square root of 3 is still smaller. So we take it again from the square root of 3 minus 1, and we end up with this pair. And the thing that we notice is that if we think of these as the size of a rectangle, this, if we look at 2 square root of 3 minus 3 over 2 minus square root of 3, we see that we get square root of 3. So this is this rectangle here is similar to the rectangle that we started with. And so if we put this in terms of, we actually construct these rectangles. So here is square root of 3 by 1, the big rectangle. And so when we take away 1, that's like taking away this square here. Then we take away, in the next line, we take away a square root of 3 minus 1. So that's like taking away this square root of 3 minus 1 by square root of 3 minus 1 square here. And we get this big rectangle here. And then we take away a 2 minus square root of 3, take away that square there. And so here is our rectangle that we ended up with, 2 square root of 3 minus 3 by 2 minus square root of 3. And we see that it is similar to the rectangle that we started with. And so that means then that we can just continue this forever. We take away another square, square, square. We take away 3 squares. And we end up with a rectangle which is going to be similar to A. And then we take away 3 squares again, and we're going to end up with a similar. And so this thing goes on forever and ever. So hence, square root of 3 and 1 are incommensurable, i.e. square root of 3 is irrational. Okay.